logarithmic function. So log is so the log really is typically inverse of an exponential function, alright? So if the basis can vary in an exponential function, the basis can vary in a log function, alright? So a log function generally looks like this. And this is where I have a slight definition. X equal a to x equal log. So remember when we did exponential, I did say that I wanted to do it that way. So let me start with my exponential and go back. What's my exponential equation that I have? What's what? Y equal a to the x, wasn't it? I say a is the base, x is the index. You understand we did that? And then, so this is an exponential. And then I want to get log, how log is connected to this one. I want you to say that, so it's going to be x is equal to log base a of y. So again, all of them is still the same. So this was the what? The index. A here was the base, and this was just the solution, or the number, some number, right? Some number can be expressed as some base to the power of an x, right? So over here, the x is the what? Yeah? It's the same thing. So this is now we're trying to solve. This is when you want to know what the index is. When you're trying to solve for the index. So this is how you solve the index. You use logarithm. So this is still the base, which is always good. And then this now becomes that's the number. So we say log to the base of the number will give me the index. So I want to know what the solution is. So how we use this? Typically, let's start with a simple one. Simple example. We know that 2 to some power x can equal to 4, right? And we solve this without a calculator by doing that. Rewriting both sides with the same base and equating it. Yes. Good? And we know the answer to this. We know the answer to this is x is equal to 2. What if I gave it this? 2 to the x is equal to 5. Well, if you could rewrite 5 and 2 to some power, then you just equate them just the same like how we could rewrite this 4 as what? 2 to the 2. Right? Then you equate. You know what I'm saying? So the principle is the same, but when you can't write the basis the same, we're into a trouble. So we use log. So what log allows us to do is take the index down. So there's a whole set of rules for log. Right? So generally, let me kind of introduce it. So if you take log and kind of LOG or LG, log both sides, you end up rewriting the left side. So what log allows us to do is to take this x, and I use the color so you can follow. The index comes out front, so the x log of 2 is now equal to log of 5. So now when you take this down, it's much easier to solve. And these can definitely go in the calculator. So if I want to solve for x, what would I do? I'd divide this side by log 2 and divide over here by log 2. So before you put them in the calculator, you should know that the answer must be a little bit more than 2, right? Yes. Because 2 to the 2 is 4 and this number is bigger than 4. So, number 2. So, but 2 to the 3 is what? It's 8. So it should be a number between 2 and 3. So if you put this in the calculator, log 5 divided by log 2, what do you get? So x would be equal to 2 points. Okay, but if you want we generally write logs sometimes with like 3 decimal places. So that's what 3 1 3 2 1.
Yes. If everyone have the third place.
Alright. But that makes sense. Right? 2 to the second is 4, 2 to the third is 8. 5 is a number between 4 and 8. Therefore, the power that you raise 2 to get to 5 would be somewhere in that gap, right? So this is a rational solution. And it's closer to the 2 than it is to 3. Right? Which makes sense. So log is what allows us to do these types of operations, to simplify solve these kinds of questions. Now, here's how I want you to connect it. You always write log to a base, right? You always write log to a base, and this is where you always have a trouble sometimes. You don't know how to write it from this form into the log form. But if you notice, the base is always the base. So you're writing a number in index form, 3 to the x plus 1. This is the base. And this will equal the some number and 1. If I want to write this as a logarithmic equation, it will be what? Log. If you don't know anything else, start with log. If you don't know what to equal to what? Log of the base. And the point of the log is to allow us to solve for the exponent. So what's the exponent here? So log of 3 must equal to log to base 3 or something must equal to x plus 1. So the only part missing is the y. So log 3 of y will be equal to x plus 1. You see how I piece together? The base will always be the base, whether in exponential form or logarithmic form. So you start with the base. So you start log of the base, where the base is, and log is to help us to solve for the exponent. So you put the exponent on the equal side, and anything else you need, you put that with the log. So it's log to the base 3 of y. So what this is saying is, what we're going to raise 3 to, what we're trying to raise 3 to get y. That's really what this means. Right? One more time we're going to multiply 3 to get y. And that is what you're going to solve for all this. Alright?
So it's not
no, you can't solve this right now. I'm just saying how you convert. You can't solve this. Too much unknowns. So you need to get something. So we get a number here, so you can't solve for it. This, you can't solve that. Right? So you needed something else to solve. But I just want to show you how you connect the two. How do you go from exponential form to write something index form and vice versa.
Sure,
Alright? So